Chapter 2, Section 2.7, Part 1. Graph each inequality on a number line. Now remember, an inequality means you have greater than or less than symbols, and you might also have the little bar underneath it, which is for equals, like in number 2, less than or equal to 3. So let's look at the first one. This is red, x is greater than negative 4. So what we want numbers bigger than negative 4. Not to include negative 4. It must be bigger. So to show that negative 4 is not a solution, we put a circle on it. And then we go to the right. Numbers bigger than negative 4 are to the right. Now an easy way to check this is pick a number that it's going through, like 0, and say, is 0 a solution? If you put in 0 for x, is 0 bigger than negative 4? Yes. So I've got it going the right direction. X is less than or equal to 3. Now, by the way, I just drew up my own number line. I would always put like where 0 is and at least one other, mark, but you could do it by 2s, by 3s, by 1s, by fractions, etc. So for number 1, I did it by 2s, but the rest of them I did it by 1s, the increments. X is less than or equal to 3. Well, that means 3 is a solution. There's two things. You want all the numbers less than 3, and you also want the number 3. So you put a dot on 3 because that's one of the solutions. That's the part that's equal. But you also want all the numbers less than 3, like 0 is less than 3. So that tells you to have the arrow going to the left. Now, anytime the x is on the left side of the inequality, whatever direction the inequality symbol is pointing will be the same as where the arrow is pointing. So here, this greater than symbol, and the arrow points to the right. That will always be true as long as x is on the left-hand side. Number 3 is a little different. It says 2 is bigger than x, or 2 is equal to x. So first of all, 2 can be equal to x, so we put a dot on it. So it can be equal, but now 2 is bigger than all the x's. All right, so this is bigger, so we want smaller numbers for x. So this has to go to the left. Now, another way to do this is to write it backwards and write x is less than or equal to 2. That's like saying if I am taller than you, then you are shorter than me. It's just the way you read it the opposite way or say it backwards. And make sure it's true. If you put in 0 for x, is 2 bigger than or equal to 0? Yes. So I've got it pointing the right direction. Notice it's the opposite. Since x is on the right-hand side, the arrow here does not point the same way it does as the greater than or equal to symbol. But when I have x on the left side, it does point the same direction as the less than symbol. Now number 4 says negative 2 is less than or equal to x, which is less than 0. This says that x is in between the numbers 2 and 0, but it can be equal to negative 2 because of this equal sign. So I could put it equal to negative 2, but it's not equal to 0. So I have to put a circle on 0, and then I want the numbers in between because it says x is in between negative 2 and 0. Now, be careful. If you've got less than symbols both directions, when you have this is called like a compound inequality, two things going on at once, really. It says x is bigger than or equal to negative 2 and also at the same time less than 0. They either have to be both less than or both greater than. You can't mix them up. And if they're both less than, the very smallest number must be on the left and the largest on the right. If they're both greater than, just the opposite. So if this had been greater than or equal to x and greater than 0, there would be no solution. There are no numbers that would work because if it's less than, you have to have the smaller number on the right, but greater than has to have the greater number on the right, so it wouldn't have worked. All right, so that is part 1, the basics. All right, part 2, solve inequality, then graph the solution set on a number line. All right, so to solve an inequality, it's exactly the same as solving an equation, except if you multiply or divide by a negative number, it switches the inequality symbol. All right. The second thing about solving inequalities is there's not going to just be one solution, one number. There's usually infinitely many solutions. All right, so let's solve this one. X minus 4 is less than or equal to negative 1, so we want to isolate the x just like an equation. So I'm going to add 4 to both sides. All right, well, you could add or subtract any number, and it doesn't change the direction of the inequality symbol. So this would be x is still less than or equal to 3. And now we're done. So we just solve it. We just graph it. You just draw a number line. And you know you have to have 3 somewhere on the number line. So how about I just say there's where 3 is and there's where negative 3. See how easy you can make it? And it says x is less than or equal to 3. So I do need to put a dot on 3 to show that's one of the solutions. Now I want numbers less than 3 as well, which is to the left. And then we make sure that the numbers it's going through are solutions. All right, so for instance, it's going through 0. So to check it, why don't you check and make sure one of the numbers it's going through is true. So check x equals 0 in the original. X minus 4 is less than or equal to negative 1. Let's put in 0 because that's one of the solutions. 0 minus 4 is less than or equal to negative 1. Negative 4 is less than or equal to negative 1 is true. So I have it going the right direction. Problem 2. 5x is greater than negative 10. So what we need to do here to isolate x is divide both sides by 5. So I'm going to write that out. I'm dividing by 5. And when you divide by 5, it doesn't change the direction of the inequality. It's only if you multiply or divide by a negative number. So this is the answer. X is greater than 2. So that's the solution. And now we need to graph it. All right, x is greater than negative 2, so I need to have 0 someplace, negative 2 and positive 2. How about that? And it says x is greater than negative 2. So negative 2 is not one of the solutions, so I need to put a circle on it. And then I want numbers greater than negative 2. Okay. And then I pick a number that it's going through, like 0 or 2 or any number you want, and we're going to plug that into the original. So I always check 0 if possible. That's an easy number to plug in for x. Check x equal to 0, and if 5x is greater than negative 10. You take the original problem, put in 0. 5 times 0 is greater than negative 10, which is saying 0 is bigger than negative 10. Okay, is 0 bigger than negative 10? Yes, it's true. So I do have it going the right direction. Number 3, negative 2x is less than 8. So to solve this, we have to divide both sides by negative 2. And that means when you divide by negative 2, you must change the inequality sign. So I'm going to rewrite the problem. Rewrite the problem switching the inequality sign, because I'm going to divide by negative 2. All right? So this gives me x, right? Because now we're just simplifying. Divide the negative 2 into the 2 and the negative 2 into 8. X is greater than negative 4. So this is our answer. Now, why did I have to rewrite the problem? The other way to do this is write negative 2 is less than 8. If you want to write divide by negative 2 over negative 2, this is wrong because that's a different answer than negative 2 is less than 8. This says, if you look at it very carefully, x is less than negative 4, which is wrong. So if you want to do that, you need to cross it off at that point, at that moment in time, and write greater than to get x is greater than negative 4. All right, so remember, when you multiply or divide by a negative, you have to switch the inequality. The inequality direction. All right, make sure you can see that. Okay, so let's graph this. A number line. Number is bigger than negative 4. So we know we have to put a 0 someplace, a negative 4, and a positive 4. And it says x is bigger than negative 4. It's not equal, so that's not a choice. So we have to put a circle on negative 4. And then we want numbers larger than negative 4, so it's going to the right. So it's going through 0. Let's make sure that 0 is really a solution. Check x equals 0. In the original problem, which was negative 2x is less than 8. So we're going to plug in 0. Negative 2 times 0, less than 8, says 0 is less than 8, which is true, so I do have it going the correct direction.